Global Biological Academy. In this video tutorial, I will discuss one previous year CSIR-NET question, and this question has been taken from 2018 in the month December. And this question is basically regarding to the enzyme inhibition, and I have uploaded 3 or 2 videos regarding to the enzyme inhibition. The link is given in the description. You can check it out. Okay, so let's see the question. For a reversible non-competitive inhibition of an enzyme, choose the plot that you would use to determine the Km. So based on that question, 4 plots are given, and that are the reciprocal plots, that is also known as the Lineweaver-Burk plot. Okay, the Lineweaver-Burk plot is the another way to represent the Michaelis-Menten graph, right? So here this blue line is indicating the inhibition, and the black line is indicating the no inhibition, when the reaction is going without any inhibition, right? So to conclude the answer, you need to understand 3 things. One is the half saturation, full saturation, and the nature of the inhibitor that is used in that case of the non-competitive inhibition. Okay, so how it interacts with the enzyme or enzyme substrate complex. Excuse me. So let's see the normal process. So before going to that, I must tell you that what is the reversible inhibition. Basically, the enzyme inhibition is of 2 types broadly. One is the reversible inhibition, another one is the irreversible inhibition. In case of reversible inhibition, the enzyme binds with the substrate with the inhibitor with non-covalent interaction, because that means that particular interaction is not that much strong enough to dissociate. Okay, we can easily dissociate the inhibitor from the enzyme with by dilution. Now in case of reversible inhibition, we can see 3 type of inhibitors that can inhibit the enzyme different way, the reaction different ways. One is the competitive, another one is the non-competitive, another the last one is the uncompetitive. Okay, so I'm not going to tell a detail about those 3 things, but I will only focus on the non-competitive inhibition that is asked in the question. Now first, you need to understand the normal enzymatic reaction. In the normal enzymatic reaction, what is the half saturation? Let's see that this particular black circles are nothing but the enzymes. For our understanding purpose, we can take these black circles as an enzyme. So these are the enzymes, right? And the blue dots over these enzymes are the substrates. Okay, if the enzyme the reaction reaches its half of its maximum velocity, means the half of the total amount of enzyme is saturated with the substrate. Suppose here 6 enzymes are taken, and if the enzymes the reaction is half saturated, or enzymes are half saturated, means out of these 6 enzymes 3 will be saturated with the substrate. So this is one, this is another one, and this is another one. So out of the 3 enzymes, 3 are saturated with the substrates, and full saturation means all the enzymes will be saturated with the substrate. So that is the case of the normal normal reaction without any inhibition. Now what will be happened if I put the inhibitors in the medium or in the reaction medium? So in that case, so again let's take a look at this particular following diagram. Here, in case of normal enzymatic reaction, the enzyme will bind with the substrate, and this is the active site of the enzyme where the substrate will bind, and it will make the enzyme substrate product. Ultimately it will produce the product, and enzyme will be free. And if I add the inhibitor, let's say that this particular red circle is the inhibitor. It can bind with the enzyme, free enzyme, and also it can bind with the enzyme substrate complex. This is the most important thing that you need to know about the non-competitive inhibition. The inhibitor can bind both with the free enzyme as well as with the enzyme substrate complex. Okay, so these 2 cannot give any product. Only when the possibility of getting product is only when the substrate enzyme substrate complex is formed. So we cannot get the product from here and also from here. As in the question it is asked that about the non-competitive inhibition. So in case of non-competitive inhibition, suppose this is about this particular situation is about the normal inhibition, normal enzymatic reaction. Now in case of inhibition, if I put this particular inhibitors in the reaction center, in that case it will bind with enzyme, free enzyme. Suppose this is the free enzyme and it binds with this inhibitor. So this is one inhibitor which binds with this enzyme, and two are saturated. So let's say these three are saturated with substrate. Three enzymes are saturated with the substrates. That means we are achieving our Km. Km means the out of the three, Km means the concentration of the substrate by which the reaction will reach half of its maximum velocity, right? Means half of the total amount of enzyme will be saturated with the substrates. So here three are now saturated with the substrates, and remaining and two are free, and one is bound with the inhibitor. That is at that particular stage, at that particular diagram is showing this particular feature. Now as this is the reversible inhibition, so after some time this particular inhibitor can be removed, and here the substrate can bind. Here the substrate can bind, and after the reaction we can get the product from here, and here these two are as it is and also as it is present. These two are saturated with the enzymes. So let's say all the enzymes are saturated. All the enzymes are saturated, but as in case of non-competitive inhibition, the inhibitor can also bind with the enzyme substrate complex. So here, not here, actually another site here. Let's say these two are now inhibited. These two enzyme substrate complexes are inhibited by the inhibitors, right? So we cannot get any product from this and from this, so no product, right? But we can get product from here, here, and also here. Okay, so it is not getting fully the reaction is not getting its maximum velocity because of this particular ternary complex. So this is now the ternary complexes are formed, but here the reaction is achieving the half of its maximum velocity. That means it is having it is determining the concentration of the substrate, that is half, that is actually saturating the enzyme, half of its total concentration, right? So from that particular statement we can conclude the answer over here. So here it is asked that choose the plot that you would use to determine the Km. So here Km will never be changed, right? So Km, so this particular line, this side is indicating the Km, 1 by Km. So here Km is two different Kms are there. Here also the Km values are different. As we have seen here, Km is not changed, so obviously the Km will be pointed together. These two lines are pointed together at the Km, so Km will be the same, so it is the Km. Okay, so here also Km are different for non inhibition reaction and the reaction with the inhibition or with the inhibitors. Now here we can find the answer, that is the answer is the 3, because here Km is not changed, but this particular this intercepting lines are indicating the maximum velocity or Vmax. This is for 1 by Vmax for the normal reaction, and here 1 by Vmax, 1 by Vmax. So Vmaxes are different as we have seen here, because all the enzymes are not fully saturated, right? So this is all about this question, and if you find this video is helpful, then share it and subscribe it. And if you have any doubt, then you can ask me by asking in the comment box, okay, so that I can learn from you also. Okay, so thank you.